Murphy's first law states that anything that can go wrong will go wrong, and when it comes to software development, simply writing good code may not be fail-proof. When software is integrated with its intended hardware system, there's a lot of room left for system failure. And for any system that absolutely cannot fail, consider building fault tolerance into your system at the software level. Overall, at a high level, fault tolerance can be defined as the ability of a system or application to continue operation after a fault, error, or failure has occurred. Any software which touches the real world can be at risk for failure. And if you're working with a critical system that absolutely cannot fail, fault tolerance allows you to keep your system running should one or more components end up failing. Ultimately, this prevents small or simple faults that become very serious failures, such as shutdowns, hardware damage, or even more serious mishaps. But building fault tolerance into your software provides you with a system that is designed to detect specific failures and mitigates a significant amount of risk, all within the software level. Can you imagine how beneficial this is to high reliability and/or safety critical systems? At the highest level, conduct a risk assessment to identify possible failure points within your system. And then once you've identified those potential areas of failure, apply a criticality rating to each scenario. When you determine the greatest risks, you can begin then to design the fault tolerance into your system. Here's a scenario for you. Fast forward a bit to where your system is fully operational. In this scenario, your team detects a failure within the system. First, confirm the error or failure message is valid by running cyclic redundancy checks. Once you have deemed the error to be valid, it is important that you then record where the detected error occurred so that when troubleshooting efforts commence, they are run more smoothly. After both detecting and validating the failure, the software team can then move forward with the recovery process. Your response to the failure should appropriately suit the given situation, being conducted in the following order. First, retry, then recover, and then finally, fail safe. By retrying, you can recover from brief intermittent issues, and if retrying does not solve the issue at hand, you then can opt to recover from the detected failure. The recovery feature minimizes corruption from the fault and allows you to access your system's original files. And if all else fails, we highly suggest using a fail-safe feature so that the detected failure will not endanger anyone who is in or near the failed system. This makes the system just as safe to be near as it would be without the failure. All in all, once fault tolerance is built into your safety critical system, your engineers can detect, validate, record, and respond to the errors by first retrying, recovering, or using fail-safe in that order. If you find yourself in need of help while looking to implement fault tolerance into your system, please contact Precision Systems. At PSI, we specialize in custom software solutions for projects that absolutely cannot risk failure, and we're always happy to help. So comment below or reach out to us at info@psi-software.com.
If you found this video to be helpful and would like to learn more, or if you'd like to learn about another specific software development related topic, let us know in the comments below or send us a message at info@psi-software.com.